All right. So when you start with oxidation reduction, you have to know the rules. We'll say the first is that pure elements are 0.
Okay.
Pure elements equals 0. Next, we'll say that the ox number
Mm.
of monoatomic ion is going to be equal to charge. So this means that, so I'll just put an example. For O2, this would have an oxidation state of 0. And then that's for that first rule. The second rule basically means if we have H+, our oxidation state is +1.
Okay.
So 3, we'll say that ionic compound must be neutral. So basically, if we have NaCl, the Na is +1 and the Cl is -1. They have to cancel out to form 0.
Mm. Yeah.
Next, we'll say that okay. All right. So beyond that, you have a few specific rules. So group 1, which is going to be your first column, same ox number as charge. So this means like sodium, potassium, rubidium. These are going to be +1, +1, and +1.
Mm.
And then we have group 1 and 2, actually. Both group 1 and 2. Let's do that. So here we have calcium, strontium, and barium. So these are all 2+. And then next, we have these specific rules that you should remember. So that oxygen has an oxidation state of -2. And we'll say that group 7 have oxidation number of -1. So basically we have Cl, fluorine, bromine. These are -1.
Mm.
And that's pretty much most of what you need to know.
Mm-hmm.
So if we start with this first question, Cl2 gas. All right. So we'll first start with listing all the oxidation states for our reactants. So over here we have sodium solid. That's going to be a pure element. So that's going to be a pure element, which means that it has an oxidation state of 0.
Mm-hmm.
Chlorine gas is a diatomic. You have Hunkelbrief. So all of these elements, whenever you have them in their pure state, they come in pairs. So it's Cl2. So this is a pure element. You have a 0.
Mm-hmm.
And then over here, you can see the NaCl. Na is going to be part of group 1, your alkali metals,
Mm.
which means it has the same oxidation number as its charge. So sodium is usually +1, or has a charge of 1 plus, which means that it has an oxidation state of +1. And then chlorine is group 7, the halogens, so which means that's a -1. So you can see that sodium went from 0 to +1.
Okay.
Yeah,
And the Cl went 0 to -1?
yeah, and then, yeah, this one went from 0 to -1. So oxidation and reduction. Reduction is going to be, well, oxidation is going to be lose electrons, and reduction is going to be gain electrons. So if we look at this, we can say that sodium, and you always refer to the reactant side, sodium oxidized because it lost an electron. Does that make sense?
Yeah.
Yeah. And we can say the opposite is true for chlorine. Chlorine reduced. So for our first one, we can say that this is an oxidation reduction reaction. Now if we do something a little more complicated, we'll look at this one. Oops, NaCl, aqueous plus copper solid. Okay. So I'm going to start again with the oxidation states. Sodium, solid metal, has oxidation state of 0 because it's pure. This is copper chloride. And okay. So copper chloride. We're going to start with the chlorine because we know that chlorine has to be -1, has to be -1, which means that copper must be +1.
Oh, okay.
Yeah, so we start over here first because chlorine is something we have in our rules. So that's like our starting point. So if we go here, look over here, chlorine is still -1 over here, which means sodium must be +1. And over here you have copper metal, which means that it's just going to become 0 because it's a pure element and it's just by itself.
Oh, so when it's just by itself, it's always pure?
Yeah.
Okay.
So if it's a pure element, it's going to be 0. So
Right. You wrote it in number 1.
yeah, number 1. So if we look over here, sodium went from 0. Sodium went from 0 into sodium with an oxidation state of +1. So this one is oxidized. And looks like we have copper went from +1 into copper without anything. So this means that this was reduced because it took in a negative charge and that canceled out the positive charge to make it 0. Basically, it's like it's like +1 plus a negative electron, and the negative electron just canceled it out. All right, so I'm just going to go ahead, extend this distance. If we look over here, we can say that, whoops, nope, no wonder. We can say that the second one is also an oxidation reduction reaction.
Yeah, but how can you say the chlorine? Because chlorine is -1 and product is also -1, so nothing happens.
What do you mean?
What can you say about the chloride?
The chlorine, this one?
Yeah, chlorine. Yeah,
Mhm.
it didn't change. So,
Oh yeah, not everything needs to change, so it's okay that it did not change.
okay. Then it's
Yeah,
just saying, oh, it's nothing.
yeah. So chlorine neither oxidized nor reduced.
Okay,
So chlorine stays the same here.
okay,
Yeah, that's all right. Basically, an oxidation reduction reaction is a reaction where something gets oxidized and something gets reduced.
okay.
So if we look at our third equation, we can see that this one probably, well, it doesn't look like this one's going to be oxidation reduction reaction. But you can see why later. Copper cyanide solid. Okay.
Oh, I think I know why.
Mm-hmm. Yeah,
But,
so mhm. So
mm, mm, mm,
hmm,
because, and then it's not the thing, the plus one side, and here is also same minus one side. Copper plus one, so it's a
mm-hmm,
plus one, and then Cn also says minus one.
mm-hmm. Yeah, that's basically why. Though
Mm,
it also helps to write down all of your state numbers so you can see. Let me see.
okay.
Okay, I should probably add in this other rule. Um, Carbon, nitrogen. Let me get my periodic table. So, oh well. In this case, normally you wouldn't just assume that this is like one thing.
Mm-hmm.
Theoretically, you would have to list the oxidation state for both the nitrogen and
Carbon.
the carbon and stuff.
Oh.
But another rule that I kind of forgot to write down is that we can say that total, or we can say the sum of oxidation numbers
Mm-hmm.
inside a polyatomic ion is the same, is, well, we'll say it's just equal to charge.
Mm-hmm. Mm-hmm.
So basically, we're going to have, it's just an example, so we have carbonate, right? This whole
Mm-hmm.
thing is an ion. So over here, we have, well, over here, each oxygen is -2, so each oxygen has an oxidation state of -2. It has a total oxidation charge of -6 because there's three of them, which means that our carbon must be +4 because this has to add up to the same thing, to the same charge as the total ion.
Mm-hmm.
So we were able to do this one because we knew it had oxygen,
Oh,
and oxygen really never changes.
uh-huh.
So that's why we could say it's -2, and because it's -2 and we have three of them,
Mm-hmm.
we're going to have a total of -6.
Yeah.
And since the whole thing has to add up to -2, this has to be a +4.
Mm-hmm.
Unfortunately, over here we have carbon and nitrogen. Neither of these are relatively like stable. They could both be anything sometimes.
Mm-hmm.
So carbon could be +1, +2, +3 or something, and nitrogen can be -1, -2, -3. So they both like to change,
Mm-hmm.
but we can basically say that the whole oxidation state for this is 1, -1.
Um,
So sodium must be +1, Cl is -1, that which we know. Copper is +1, sodium's this one. So using this, we can see that none of these change.
but if the CN was other molecule, and
Yeah,
we have to separate them if we want to do it with another molecule.
yeah, most of the time you will have to end up separating things.
Okay.
But in this case, we couldn't do anything about it.
Uh-huh.
So what we basically said was, we know that sodium must be +1.
Mm.
So we put down that +1,
Mm.
and we know it must be uh, neutral,
Yeah.
which means this whole left side, the whole right side must be -1.
Mm-hmm.
Um, Theoretically, you would, this just so happens to be the same thing as the periodic table, the group numbers, or the charges. So
Mm.
carbon is going to be +4, and nitrogen, oh, sorry, that's not correct. Carbon is going to be, actually, sorry, I don't quite know. So yeah, you really
Okay.
wouldn't be able to split them up because you don't know what the oxidation states are. Not yet.
Um,
All right, but that's it.
Mechanical